This is a demo video for the multifunction control unit and associated PC application. Upon starting the application, the user is presented with the initial default page, which can be seen on the screen. The default page is blank, ready for the user to either load a configuration file or start making a new one. The user doesn't necessarily need to connect to the multifunction control unit in order to make a new setting. This step is only required when sending the settings. I will now run through how the user goes about making a new setting. The setting to be made will be for a headlight. The headlight is currently connected to output 9 on the device. The input switch desired is a 3-position switch, which is connected to input 4. First step the user has to make is selecting the headlight through this light effect menu. Then they will select the input purpose. That is the 3-position switch discussed earlier. This is merely just to aid them in determining what they've just configured. The input pin desired is input 4, because that's the connection for the channel which is connected to the input 3-position switch. They want it to trigger when a value is reached or is greater than, so that's the rule. And the output desired is output 9. That is the LED headlight. Of course, headlights don't typically flash, so the only option they have right now is a static on signal. And the user most likely wants a value of 30% or more for the input switch to trigger the output. This concludes configuring a setting. Right here, you can see that the setting has been configured, and the user clicks here to view the setting. Having made a setting, the user can now save a setting. To do this by pressing Save Configuration, they then specify a name. In this instance, I'm going to call it Test. Or this will then be saved. The user can then load the setting from the same location. If I go about deleting this setting, as seen here, by clicking on it, it's clear. As you've seen, you cannot click on it. The user then loads the setting that they just saved. And now it's back. This concludes the saving and loading demonstration and the creation of a setting demonstration. I will now demonstrate how to connect to the multifunction control unit. In order to connect to the device, the user must select the right COM port. In this instance, COM port 3 is the correct COM port for the device connected. Upon selecting this, the user presses Connect to Multifunction Control Unit. This is now paired the device with the application. This concludes the demonstration of connecting to the multifunction control unit. Now that the device is connected to the application, the user can go about uploading their now configured settings. In this instance, the headlight is the setting that's been configured. To do this, ensuring that you are indeed connected, sending settings to multifunction control unit is the button to press. Upon completion, you will get your settings were successfully uploaded to the multifunction control unit. This concludes sending a setting to the multifunction control unit. Now that the device has been connected and the settings have been sent, the user may wish to get the device status. To do this, the user needs to press Get Device Status. Upon pressing this, the screen should be updated with the current input and output values. At this point, we can see that when I move the input 3 channel, it varies with an appropriate rate, and that no matter what I do, all the outputs remain off. The only output in this instance that should toggle is output 9 headlight, which is connected to the 3-position switch, and when I flick it to the first position, it's triggered on and then off. When it exceeds 30% as set previously, which it does, it's on. When it reaches below 30, it is off. This concludes the demonstration of how to monitor the output status of the device. To save time, I've made a fuller system. I will now load that system. This configuration includes headlight, main beam and high beam, front left and right indicators, a reverse light, front and right rear indicators, a brake light, and a license plate light. Now to send the settings have now been configured. The vibration drive is now active because we have a throttle. Here we can see outputs 1 and 9 get toggled on and off with the change in inputs 4. License plate light, output 2. Indicators left, output 3 and output 8. Indicators right, output 5 and output 6. Reverse light, most of the way. Brake light, output 7. This concludes the full system. A short video demonstrating what it actually looks like will be included towards the end.